So I think the last discussion is we call it variation of parameters. Just a little bit of review what we have done at the last method for our chapter 3, the higher order derivative. Suppose we have the second order. It's a non-homogeneous. Now every time we have a non-homogeneous, whatever method we are going to use, the first thing we are going to, or what we could do is we are going to take the auxiliary equations. Take auxiliary equations and check the roots. And there are three cases, remember? There are three cases. The root is real, distinct. The second is repeated root, real. The third case is a complex conjugate, in which we are going to have the alpha and beta in the Euler formula. And for our case here, we are going to have the m1 equal m2, which is the repeated root. So that means we are going to have the first component is e with power of this 2x. Remember the format is e with power of mx. And then if it is repeated root, we are going to make the second component linear independent, in which we are going to multiply with x. So this becomes linear independent. Okay. Now the next part, we can do this in undetermined coefficient, because we have, I think it's not really that complicated for the right hand equation. So we can do the undetermined coefficient. We are going to multiply with e. Okay. But now let's try the Wronskian, the variation of parameters. What we are going to do is we take this e, this 2e, this component, as our y1 and y2. y1 and y2 will be part of the Wronskian component that we are going to use. So Wronskian is going to have this y1, y2, and the second part here, the second row, is going to be its derivative. Derivative of the top. Okay, top. So derivative. And then take the determinant. You get this as your result. It's over your Wronskian. And then we are going to do, actually this is what we call the Cramer's rule. And the Cramer's rule is one method to solve linear equations in matrix, in matrix system. So we are going to change this column, the first column here, with this. This is based on, I think if you remember what we wrote before, the zero came from the u1, y1, blah, blah, blah equals 0, and then the second part is equaling to the right side. Okay? But you can just always remember that this is supposed to be 0 and the right-hand equation. And then that is our W1, and we've got also W2. We changed the second column. Okay? And then we take the determinant, get the result, and based on the Cramer's rule, the U1 prime is W1 over W, and the same thing with the U2 prime, it's W2 over W, and we get the results, and we integrate to get our U1 and U2. U1 and U2 is part of the component of our particular solution. Okay. A particular solution, U1, this is Y1, U2, Y2. So the part that you need to look for, always remember that our particular solutions will be in this component. Okay. So our goal in the variation of parameter is to check this U1 and U2. Okay. To check and get the result U1 and U2. And then at the end, we put all this U1, U2 with Y1 and Y2 as our particular solution. Okay. But if the question is asking the general solution, then you need to plus with the complementary solution, which is YC. YC is practically the first solution here. So the total solution, the general solution is this part plus YP. YP is this. Okay, well, YP is this. We have a quite long solution for this one. Okay. I think if you would like to try using the unlimited coefficient, perhaps we are going to see there will be something, some differences, okay? But I think it's still okay because we have the constant in the YP, so that's still okay. The Wronskian also works if we increase our order. For example, third order, fourth order. The difficult part is the matrix. It will be 3 by 3, 4 by 4. And the 0, for example here, the second order has 0, right? The third order will be 0, 0, and then the right-hand equation. Okay. So it's supposed to be has the same pattern. Okay, have the same pattern. But I think I will just limit it our exam until the second order, because we still have another part in our course that is about the matrix. We haven't yet get into matrix, but we are using the matrix matrix solution. Okay. Okay. Okay, I think we can move to the next sections. So this part and the previous part and later the next section, I will attach one exercise, maybe around 7 or 8, maybe 7 questions that includes at least the chapter 3 for your preparation for exam and so on. So midterm will be next week, okay? Tuesday. Tuesday, okay? Okay, I will prepare the questions so that the question will be not really, it's supposed to be sufficient within the 2 hours time. Okay? Okay, let me go through the next section, which we call the Cauchy-Euler equations. Okay, now let me write the typical or general form. Okay, so linear DE form of this Cauchy-Euler. So let A and X Okay, this is the general form. Okay. So what is this about? Okay. What things that you when you look at this formula, it seems that the formula has a particular pattern. If you look at the n, and you look at the n, and here, and here, and here, and here, all the same. Okay. This is n minus 1, n minus 1, n minus 1, and So all the order and the power, they are in the same number. Okay? They are in the same order and power. But what we are going to check, okay, in particular, within this section, is the second order. Okay? To give you clear examples to check the second order. So the second order, let me use b to make it different coefficient. Bx dy dx plus cy equals 0. Okay, let's start from the homogeneous. So let's start from this is homogeneous. And from this homogeneous, we can solve the non-homogeneous, right? So let me write again the same. But we need to take the interval. We need to take the interval from 0 to infinity. Because at x equals 0, it will be a problematics. Will be a problem. So the definition should be on the interval from 0 to infinity. Okay, now the first thing we need to try the solution y equal x with power of m, where m is something that we are going to determine. So it's similar with the previous one. The previous one is we are taking the e, right, with power of something, but now suppose that we are going to check with x to the power of m. So we are going to, let's say we try to solve the second order. So at least we are going to have the second derivative from here. So, sir, the first thing is derive. So derive, this will be m, and then x, m minus 1, and then y double prime, this will be m minus 1, x, m minus 2, right? So substitute, let me write again, this is ax squared. Let me write with y double prime like that, plus bx y prime, plus cy equal of g of x. So let's substitute. This will be m minus 1, okay, plus bx x m minus 1. Oh, I forgot the x. Wait. And then the last one is cxm. Okay, now take the x with power of m out. Let's factorize because all have the x with power of m. And zoom in to make it clear. Okay, now we have x with power of m. We take outside, so we have x with power of -2 still inside. We can cancel this with this, right? And this also we can cancel with this -1 here, right? Okay, so I think we are getting a simplified equation. I think it should be okay. So a m m -1. So a m m -1. Okay. Or maybe we'll just write it like this first. Plus bm, right? Plus bm and then plus c. So first is like auxiliary equation, so we are going to equaling this to 0. Okay. So this let me write notes here. So auxiliary equation is homogeneous, or g of x will be equal to 0. So this is equal to 0. And notice that x cannot be 0 from our definition. So the one that makes 0 is this part, right? So this part is I think it's kind of similar, have a similar vibes with our previous auxiliary equation. And because we are going to have multiply, we have something like the quadratic, or it's a quadratic equations, right? So we are going to have the same case, 3 different cases. So the distinct root, the repeated root, and the complex conjugate, the same thing, but a little bit different in conclusion. So this will be our auxiliary, or if you want to take the expansions, so we take the am squared plus b minus a m plus c. Okay, either one is still okay. So case 1, we have distinct real roots. Let's say we have m1 is not equal m2. So our y1 is x with power of m1, and y2 is x with power of m2. Okay, let me go through one example for each case. So x squared, let's say this is y double prime minus 2x, y prime minus 4y. Let's say it's equaling to 0, okay, equaling to 0. Actually, Cauchy-Euler is best to take the complementary or the homogeneous part. So if you have another, let's say, another equation here, then you could take on another method to complete the solution. The solution for this part here is the best way to solve the homogeneous part. Okay? For example, when it's equal to 0, 1. Okay. The thing is, before we do anything, like when you're dealing with some questions and you see that the squared here, okay, it's also the second order, this x, the first order, right? And then this is a constant and it has phi. And we are certain that this is our Cauchy-Euler forms. Okay? And we could take the Cauchy-Euler by taking this auxiliary equation, or this one also okay. So we could take A is 1, B is -2, and C -4. So we could take the A is 1 m squared plus B minus A. Oh, let me write here. A is 1, B is -2, C is -4. B minus A, so B is -2, -1, -3. So it's supposed to be -3m. And then C is -4, so -4 equal to 0. And I think we can factor this out. So m minus 4, m plus 1. Okay. So this implies that m1 is -1 and m2 is 4. So because of this, then we could have the solutions is x, or constant x -1 plus constant x with power of 4. If this is a non-homogeneous, we have another one here. I think my suggestion may be taking variation of parameters. So you have y1 is this, y2 is this. You can take this directly, take the Wronskian, equaling to the sides here, and then later you can make it to 0 and this equation here, whatever it is. And check the determinant, and I think that will be good pairing, okay, this method and then the variation of parameters. The variation of parameters, at least they need to have the y1 and y2 for second order. So again, the Cauchy-Euler, you need to have this or this as your auxiliary equations to get your m. And this for the second order, you have two m's, m1 and m2. Okay, this is case 1. Case 1. Okay. Now case 2. This is for the repeated roots or repeated real roots. where m1 is equal m2. Okay, so repeated real roots, if you remember in your quadratic equations, in our equations, let me write the auxiliary equations. Usually, our quadratic formula, we start by taking the negative b minus a, right? Plus minus square root of b minus a squared minus 4ac, right? And then divide by 2a, okay? The first case, we've done that, and we have this square root is positive, the result is positive. Okay. But here in our repeated real root, this one will be 0, right? It will be 0. Okay. This will be equal to 0. So we are going to have okay, let me write again the Cauchy-Euler. Or let me copy from here. Where's the standard one? This one. Let me write here the standard. We can rewrite this, okay, and take this into, so divide all with, so multiply with 1 over ax squared. So y double prime plus b over ax, and then y prime, and then plus c over ax squared y. Okay. Let me write the standard second order. Okay, and then remember the reduction of order. Okay, so reduction of order. So we take this b over ax as our px. So p of x is b over ax. And then if we take the integrations, this will dx, this will be equal to b over a, 1 over x will be ln. Okay. And our reduction of order, let me write with different color. So we're supposed to have our y1, which is the, so y1 is x with m1, right? So we are going to check the y2. If you remember the reduction of order, reduction of order is we are simply finding the y2 from our y1. So y1 will multiply with the integral. So y1, or in our case, this is x with power of m1, and the integrations. E with power of the integration of px. Okay. So let me write directly here. Ln x. I think should be negative. Having negative. So this should be negative px. And then x. And then 2m1. And then the x. And then this will be x m1, and the e negative b over a ln x. We'll move the x to the top equations like that, and then still have the x here. Now, in our case here, this negative b over a, I'll put here, okay? I'll put here, and then e and ln will be canceling each other, right? E with power of ln, okay? So we can write x with power of negative b over a multiply with x with negative 2m1 dx, okay? Okay, m1 is this, and we know that m1 itself is this, right? So we could take this into 2m1 is negative b minus a over a. Okay, so we change this m1 so it's negative, so it's become positive, right? B minus a over a. Okay. So this is supposed to be equaling to so what's happening now? It's b over a plus, so what will happen? It's going to be minus b plus b is 0, so negative a over a is negative 1, right? So it's going to be x negative 1. Okay, so this will be 1 over x dx. Okay, and it's simply x m1 and then ln x. Okay, since we are going to have like reduction of order along the way here, but the conclusion is very simple. We just add ln x to make it linearly independent. Before, we multiply with x, but now it's not really works because we are having the exponent with the base of x, right? That's the problem. Because if we multiply with x, then it's still linearly dependent. So we need to make it linearly independent, and the best way to take linearly independent is taking it through the reduction of order, finding the second solution, the y2. So yeah, it's a little bit complicated, but the conclusion is just multiply with ln x. Okay. So general solution. Is y c1 x m1 and then plus c2 x, still m1, but it is ln x. So this is the y2. Oh, from where? This one? The original equations, if you want to remember, this is y2, y1 square, this is e negative bx dx, this is y1 squared dx. how if we have, what about if we have the repeated roots? Maybe it's not just 2 roots, maybe 3, 4, but repeated roots. We are going to play with these ln. So we are going to multiply with another ln. But for our case in our course, I will limit this just second order. For Cauchy-Euler for second order. Okay, so the first case, distinct root. Second case, repeated roots. I have been giving this example. Okay, let me give you example. Example is let's say 4x squared So we could get directly, this is first, before we try anything, we could see how it looks like. Okay, we see the x and then component of x and then the y. We have the same order, the same power in each component. So we could imagine this is A, B, and C, right? So A is 4, B is 8, and C is 1. So we could take the 4m squared plus b minus a is 4m plus 1. Okay, so we have, this is 0. Now we take our time to solve this. And we have 2m plus 1. Yeah, 2m plus 1, right? Squared. So 2m plus 1 is 0. So m1 is negative 1 over 2. So we have repeated roots. So we have repeated roots. So the general solution, we can write directly from this m1, y is c1 x power of negative half plus c2 x negative 1 over 2 ln x. So just add ln x. Okay. So the next case is a little bit the most difficult one, I think. Case 3. This is conjugate complex root. If roots are conjugate pair, let's say M1 is alpha plus imaginary number beta, and M2 is alpha minus. Okay. Alpha and beta, they are positive and real. Then solution is C1 y alpha plus this, and C2 y alpha minus this. But we want to write the solution in terms of real functions only. So we are going to take notes that, oh, why this is y? Should be x, sorry. Should be x. Okay, notes the identity of x with power of imaginary number beta. We can write in terms of ln, so we take the e and then power of ln x of this imaginary number beta. This is, we can write like this. Okay. And by Euler formula, this is going to be cosine. Now this becomes beta ln x plus sine beta ln x. Usually we have the beta in the Euler, but we change the imaginary number beta with this. And if we have the negative counterpart, okay. Now we add these two and subtract these two. So when we add, we have 2 cosine beta ln x, okay, because the other component is canceling, and we minus these two. So we are going to have 2i sine beta ln x. Okay, remember the fact that we have general solution from the previous one is C1 x alpha plus imaginary beta plus C2 x alpha minus imaginary beta. So these general solutions, when we write here, we could take this solution for any constant, right? Any constant. And now, to make this compatible with our two components here, which means we are going to have C1 and C2 for this one is 1, 1. So C1 is 1, C2 is 1. For this part, the second one, the C1 and C2 will be 1 and negative 1. So from here, we take notes from this one. C1 is 1, C2 is 1. For this one, C1 is 1, C2 is negative 1. Okay. Now, from this constant, we can take the x alpha, okay, x alpha. So y1 is x with power of alpha, and then x okay, let's say this is y1, and y2, this is from the constant we have. I think we can write later. So y2 is x with power alpha, or we can write the y1 is 2x alpha, and then we can change this plus with this cosine. So change the cosine beta ln x, 2 cosine beta ln x, okay. And y2 is 2i x alpha sine beta ln x. Okay, I think we will have a break. Okay, we still have not yet have a conclusion here. Okay, we continue. Okay. So essentially, y1 is this, okay? 2x to the power of alpha cosine beta ln x, and y2 is 2 imaginary number x to the power of alpha sine beta ln x. But the conclusion is a little bit how to say weird from here, because first is we don't want to write this imaginary number. Okay. So what we could propose is the part that has only the essential features of its function. So which, for example, the y1 is x to the power of alpha cosine beta ln x, and y2 is x alpha sine beta ln x. Okay. So from that two features, we could take the Wronskian, okay, to check. So take the Wronskian and checking the x alpha and then cosine beta ln x. The second one is x alpha sine beta ln x. Why we need to check the Wronskian? Because we need to check whether these two are linearly independent or not. Okay. You could try that yourself if you want, but I think it's a little bit long. So I would just write the conclusion that this is not equal to 0, which is linearly independent. Or let me write this is equal to b x 2 alpha minus 1, and this is not equal to 0, which means that these two, they are linearly independent. Okay. And of course, the beta will be positive on interval 0 infinity, as we defined from the beginning, right? From the beginning. So conclusion is y1 is x with power of alpha cosine beta ln x, and y2 is x alpha sine beta ln x. Okay. So they are our fundamental set of real solutions of the differential equations. So the general solution from this y1 and y2, we can just add a constant. We can just add constant to both of these y1, y2. So y is equal x with power of alpha c1 cosine beta ln x plus c2 sine beta ln x, and that's it. Okay. So I think that is mostly all the techniques in chapter 3. Okay. So next week, the midterm will focus on chapter 2, chapter 3, the first order and the higher order. And to make your exam convenient for you, you can prepare your A4. You can prepare your A4. You can write anything. You can write anything. But my suggestion is write something that is really, really obnoxious like this. Okay, I think you can practice on your own. Okay.
Is it allowed for both sides?
Yeah, both sides are okay. Both sides are okay. Both sides are okay. I need to handwritten. Okay, you have to use pen. Okay, just to make sure that your note is your own. Okay, your note is your own. Because I'm worried that maybe you will take somewhere else and everyone do the same. So it doesn't have any originality. At least you have your own notes, right? Okay. So I hope it helps. Okay, I hope it helps. So yeah, I will make sure that the question can be answered in 2 hours. So yeah, it's like it's like introductory to falling asleep. Yes.
Are we still allowed to use calculators?
Yeah, calculator. You can bring your calculator. Because sometimes you are going to confirm your answer through calculator. Okay, my example for the third case, okay, let me give you example with initial value, so we will have more insight on how to solve the problem. So let's say we have initial value problem. For x squared y double prime plus 17y equals 0. Y at x equal 1 is -1. So there is no y prime, right? It's still okay. It's still okay. We can still use the Cauchy-Euler. But to make sure that we are doing it correct, let me just give you the the proof method like usual, like the beginning, like we have the m so we take 4x squared y double prime plus 17y is equal 4x squared m minus 1 x and then plus 17x m, and we take x with power of m outside, and this x and this 2 is going to cancel, so we are going to have 4m minus 1 plus 17. So we have this, or we could take the 4m squared minus 4m plus 17 equal to 0. I don't think 17 can be factorized, so I will just take the quadratic formula. This is 8. This is negative b, so it's 4 plus minus square root of 16 minus 4 multiplied with 17. So 17 and 4 is 68. So this will be, yeah, negative 52. Negative 52. So it should be half. Oh, should be multiplied with another 4, sorry. So what this is, 272, 6, or 256, 256. Okay, but you can check by yourself. Plus minus, this will be 2 imaginary number. So m1 is half plus 2i, m2 is half minus 2i. So alpha is 1 over 2, beta is 2. We could take the general solutions. So y is x with power of alpha, and then c1 cosine 2 ln x plus c2 sine 2 ln x. Now take the initial conditions. So y at x equal 1 is negative 1. So first is take the x equal 1, so y is 1, or c1 cosine 1 cosine ln 1, sorry, cosine 2 ln 1 plus c2 sine 2 ln 1. This will be 0, this will be 0. So the whole thing here is 0. and this one here is 1. So y is equal, C1 is equal -1, so C1 is -1. And then take the first derivative. Take the first derivative. Yeah, at least you need to take the product rule. So x Oh, you can take the product rule, just take the bracket. Just take the bracket. So this will be 1 over 2 squared x, C1 cos 2 ln x plus C2 sine, and then plus x. Okay, and then derive the inside. It's really long, right? Okay.
2 over n
Sine
sine
2 ln x, and then multiply with 2 over x, right? And then plus C2 cosine 2 ln x, and then multiply with 2 over x. Okay, still doable. So y prime at x equal 1, so at x equal 1 is equal half. We know the C1 is -1, so we could write negative. So negative cosine 2 ln 1 plus C2 sine 2 ln 1 plus x is 1, so we can ignore that. C1 is -1, so it's positive now. Positive sine 2 ln 1, 2 over 1 plus C2. This is, I think it's supposed to be 1, but let me just write 2 ln 1 just in case. So it's half. This is 0, so this is -1, so -1 plus it's 0, so it's -1, right? -1 plus this is 0, this is C2, 2C2. This is equal to 0. So negative half, or 2C2 is half, or C2 is it? Is there anything wrong here? Let me check. Anyone can check? Yeah, here. Anyone can check? Is there anything wrong? I think something's wrong. Oh, yeah. Okay. Thank you. So 2C2 is okay. Now it's C2 is 0. Okay. Thank you. Okay, now we could write down the total So solution is, so C2 is 0, which means that the whole thing here is 0, right? The whole thing here is 0. Or where's my solutions? Or here. So this will be 0. So our solution, we can write y is x with power of half. And then this is, or we could directly write cosine. And then 2 ln x. Do you think this process difficult? I think not
It's just
difficult,
long.
but long.
It's long.
Not difficult, but long, I think. Okay? If you take patience, I think it should be okay. But it takes time. It takes time. Yeah, it takes time. It takes time. Yeah, so that's how difficult to make a question. I need to make a question that's supposed to be, it has a certain difficulty, but when you take it, and when you understand the question, it doesn't really take really long time to process. So if it is like you understand, but it takes a long time to process, I think that's not really a good question. But yeah, that's how difficult to prepare questions actually. Yeah, you'll notice when you teach someone, or like maybe someone asking, like maybe from your juniors, like for example, anyone from high school asking you about calculus or any mathematics problem, and you need to give them like a context that they are quite relate with those all the content. If not, then they will be like, oh, what is it? It's like really in the alien world. Okay, this part. Okay. Okay, I think I can give you the, if we combine this with the non-homogeneous. So all the things with the Cauchy-Euler is actually for homogeneous equations when it's equal to 0, like the auxiliary we had before. This is actually the same. So when we have non-homogeneous, we need to combine with another method. For example, the variation of parameters. I think that is a good combination with this Cauchy-Euler. So let me give you that example. Okay. So let me give you okay, we solve this. Okay, so first is solving. So always solving the homogeneous. Okay, homogeneous part. So whenever you have a non-homogeneous, the first thing is solving the homogeneous part, which is we need to equaling this to 0. And we know that this is a Cauchy-Euler. So we could take this and equaling it to 0. And from what we can see, this is A is 1, right? B is -3, and C is 3. So we have m squared plus b minus a, and then plus 3 equals 0. So this will be m squared minus 4m plus 3. So this will be m minus 1, m minus 3. Okay, right? So we have m1 is 1, m2 is 3. Or we could take the solutions. Now the solutions in Cauchy-Euler, it's become our complementary, our YC. So this will be C1 with x plus C2 with x cubed, right? Okay, now we solve non-homogeneous with the help of our YP. So we need to construct our YP, right, the particular solution, so that we can combine this YP and YC to make our general solution. If we want to take another method, for example, the variation of parameters, the important thing is we need to look at the structure first. Remember, when you have the variation of parameters, this x squared is not in here, right? We need to have the clean y double prime only. So we need to divide all with x squared. So let's divide all with x squared. So, or maybe let's take let's copy this and write a new equation. So divide by 1 over, or multiply with 1 over x squared. So this will be y double prime minus 3 over x y prime plus 3 over x squared y. Okay. And then the right hand equation also we need to multiply and becomes this. Okay. Now this equation we can solve now through the variation of parameters, right? Okay. We can construct now. So we can identify that this will be our f of x, or any g, h, any variable you can take, but that's our functions. Okay. And y1 and y2, we could take this as y1 and y2. So we could take the y1 is x and y2 is x cubed. Now with the help of this y1, y2, and f of x, we could construct our Wronskian. So the Wronskian, first Wronskian, you can take x cubed, and the second row is the derivative of each of them. So this is 1 and 3x squared. And then Wronskian 1, which means the column of 1 is changing to 0, and the f of x, the 2x squared ex, and then the same here. And then let me write all the Wronskian first, and then we can compute the determinant. And the second one, x1, and then this one is 0, and 2x squared ex. Well, aside from variation of parameters, I think we could also take the undetermined coefficients. Yeah, I think we could take that also. But let's say we are going to use this variation of parameters, because I think variation of parameters is if the y1 and y2 is not really that complex or complicated, I think the variation of parameters will be easier. So we take the determinant, so this minus this. So 3x cubed minus x cubed is 2x cubed. So this will be 2x cubed for the w. W1 is 0 minus the minus 2x 5 ex. And w2 is 2x cubed EX. So U1 prime, this is for, let me give you an idea how we get this. So we need to write this equations for YP in variation of parameters, right? So we need to take U1 prime from W1 divided by W, the Cramer, this is the Cramer's rule actually. So we take this, divide with 2x cubed, so this will be cancel, so cancel 2, so we have negative x squared e with power of x, and U2 prime is similar, so right, so cancel, so we have e to the x. Okay. And we need to take the integral. And also take the integral of this. I think this is easy, just e to the x. And how about U1? We can take the integration by parts. Negative x squared and ex. Let me write down here. So negative x squared ex plus 2x ex minus 2ex. Okay. It's U1. So U1 and U2, we combine both, becomes and we need to multiply with x because y1, and then plus U2 is e to the x, and the y2 is x cubed. I think we can see that this will be this. We can cancel this, so we have this, our YP. So YP is 2x squared e power x minus 2x ex. So y is yc plus yp, or this is c1x plus c2x cubed plus 2x squared e power x negative 2x ex. And I think this is all the topics for the midterms. Okay. Okay, later or maybe tomorrow, I will prepare some exercise for you. And yeah, hopefully the midterm will be kind of similar, but not similar, but maybe take the difficulty is maybe same difficulty. But I think it's more difficult for exercise, so I'll give you more questions. Okay, any questions? Any questions? If not, I will just finish something here. So,
What do we homework in addition to the exercise or just the exercise?
just exercise. think I will be starting homework if the midterm is low. Okay, homework. Just in case for additional points. But later I will give it to you. So actually next Thursday, this Thursday, perhaps we are going to have some sort of evaluation on part of the problem in your exercise. I will pose as soon as possible, but I think tomorrow. You can just take a glance which questions that might maybe take some interest on some question, and we can have a discussion on Thursday for question and answer. All right. Okay, if there's no question, so we'll finish, and I will have some feedback as usual. Okay. Okay, this is about the undetermined coefficient. Hopefully you still remember how. I think I give some 20 minutes. I think 22 minutes for each question. I just two questions. So you compare with the first order differential equations. I think the higher order one, you will notice like what techniques you are going to take before you process. In the first order, you can have several ways. Some of the method maybe becomes more complex, but you need to yeah, it's also another experience to have if you want to consider which method is really can be utilized on particular question. Okay, we'll can start. Okay, we could take your ID. Okay, we can start now. So 4 minutes, 30 seconds, so 4.5 minutes. I hope this is optimized for you this time. If not, then of course I will rethink how to prepare your midterm exam. So you can take the undetermined coefficient and then take the coefficient A, B. Or perhaps you would check from the options. Yeah, if you have time, you can check the option also. Yeah. You will see some ambiguous options. method? I think variation of parameters. I think we will have to conjugate complex. Yeah, perhaps should be maybe 6 minutes. Usually in 1 minute or 2 minutes you will froze for a while. Yeah. Right, okay. It means that you need to check the auxiliary equation first. And important to have. Yeah, that's the challenging part. So we didn't take you to directly to the YP before you understand the auxiliary equation. That you need to have some restriction. Okay. Okay, good.
Because it's science.
Who is Elsa? Who is Elsa? Anyone? Okay, I think you can change. You can change your student ID. Anyone name Elsa? Oh, okay. Okay, the second questions? Yeah. So you find the undetermined coefficient using the quadratic. So you just have the ax squared plus bx plus c. Differentiate twice. Plug it into here. It's take like really long, so I hope you have enough space for writing the equation. The equation is not too difficult, but it's like really long equation. And after finding out the general solutions, then you can plug in the initial value, y0, when x0 is 0, and when x is, for y prime and x is 0, is also 0. Yeah, also, it's about 4 minutes. I should have this, I think, 6 or 7 minutes. But this is just 4 exercises. I think this is, I think if this question somehow appear in your exam, it should be okay, right? It should be okay. Like maybe 10 to 15 minutes to work this out. I think it should be sufficient, right? 10 to 15, right? This is exercise, so the time is really fast. have goals. We have additional 2. Perhaps using different account. Or maybe someone else
Send the curriculum.
outside this classroom. They were still okay. Yeah, they have their effort. Let's take this one. Although they are not in the class. Oh, 23. At least some of you know your culinary over there. Okay. Okay. Yeah. It's a little bit complicated, but yeah. Okay, good, good job. Okay, so yeah, last part, your ID and any feedback. Okay. I think next week midterm, and then the Thursday class is another introduction for a new chapter. The next chapter will be the Laplace transform. The Laplace is actually the integral, but we have changed those integral with some process, and we simplified with we call the Laplace. Okay, so that's all for today. So see you this Thursday.